All right, we're going to go ahead and start with a function that looks like this. If I have 2x plus 7 times 3x minus 1. Right now, the way that you know how to do this, to take the derivative, requires us to multiply this out first. So if I multiply this out, I get 6x squared minus 2x plus 21x minus 7. Or f of x is equal to 6x squared plus 19x minus 7. Of this is 12x plus 19. Now, I want to show you another way to do this. In the second way, while not required for this question, can be required for other questions. Let's go back to our beginning function. F of x is equal to 2x plus 7 and 3x minus 1. We have a rule called the product rule that says if f of x is equal to two different functions being multiplied times each other, let's call them g of x and h of x, then that derivative is equal to the first function times the derivative of the second plus the derivative of the first times the second function. So let's go ahead and do this. What I'm going to do is keep my first function the same. So that is going to be 2x plus 7. Now I want to take the derivative of the second function, which in this case is 3. Add that to now my second function, which is 3x minus 1, times the derivative of the first function, which in this case is 2. And let's see what we get. If I multiply this out, I get that as 6x plus 21. And over here, that is also 6x minus 2. So yes, and those numbers should look familiar. It is 12x plus 19. Let's go ahead and take a look of another example with product rule. So if I go ahead and call this first piece, this first team, we'll call this u, and we'll say u is equal to x to the 5th. And v is the second parenthesis here, and v is equal to the square root of x, but I'm going to write the square root of x as 1/2 plus 2x plus 1. I want to find the derivative of both of these. Using the power rule, u prime is 5x to the 4th power. And again, using the power rule, v prime is equal to 1/2 x to the negative 1/2. And again, that's 1/2 minus 1 will equal negative 1/2 plus 2. So to find the derivative of f of x, what we want to do is, again, u times v prime. So that is going to give us x to the 5th times 1/2 x to the negative 1/2 plus 2. I want to go ahead and add that to u prime times v. Which is just 5x to the 4th times x to the 1/2 plus 2x plus 1. Now I want to go ahead and simplify all of that out. When I go ahead and multiply, I add exponents. So that is 1/2 x to the 9/2 plus 2x to the 5th. Over here, the next group of parentheses, when I go ahead and multiply all of that out, I am left with 5x to the 9/2 plus 10x to the 5th plus 5x to the 4th. And if I combine like terms, and I can combine like terms of x to the 9/2 and also here, I am left with 11/2 x to the 9/2 plus 12x to the 5th plus 5x to the 4th. Now, if I want to check that, I can check that by starting with f of x and multiplying that all out first. That would be x to the 5th times x to the 1/2 plus 2x plus 1. If I multiply all of that out, it would give me x, and again, remember we are adding exponents here, 5 plus 1/2, and that gives me 11/2 plus 2x to the 6th plus x to the 5th. And if I go through and find the first derivative this way, using the power rule, the 11/2 comes in front. I subtract 1 from 11/2, which is 9/2 plus 12x to the 5th plus 5x to the 4th. So yes, that does work. Now, there's going to be times later on where we're going to use the product rule where we can't verify it this way, and the functions get a little bit more complicated.